Okay, so just a couple of quick announcements. This is kind of the same as you've seen before, but the last day of the school year is this Friday. If you have an F in this class and you are a senior, you need to get on that by Wednesday so that we make sure we know who is going to be able to get to graduation and who is not quite going to be there and who is going to need to finish over the summer. Juniors, you have until Friday. We still need to know who's going to finish the class and who's going to get the credit, but since you have another year before you graduate, it's a little bit less pressing. So that's that. All of your late work is due on midnight, the day that I asked for. So yeah. Okay, really quick before we can do this lesson, you have to know this vocabulary word called coterminal. A coterminal angle is an angle that points at the same place around the unit circle as another one. And so an example of that would be the red one, but then also this blue angle where we went all the way around the circle and then we went to this. So this would be like a 60-degree angle. And then this one would be like whatever 60 plus 360 is, which would be 420. So those two angles are coterminal. In radians, we can do the same thing. And so this is a pi over 3 angle. And the other coterminal angle would be whatever pi over 3 plus 2 pi is, because 2 pi is one time around the circle. And so if we add 2 pi, then we should get to another coterminal angle. So find a common denominator, pi over 3 plus, I guess, 6 pi over 3, huh? And that would give me 7 pi over 3. And so this is another coterminal angle to this angle. Basically, what you need, and especially for our class, really what we're going to be doing is we're going to be using radians. So if you know a theta, which is any angle, if you take a theta and you add 2 pi to it, or subtract 2 pi, or you add any number of 2 pi's or subtract any number of 2 pi's, then you have another coterminal angle. Okay, so we might not need coterminal angles yet for this part, but let's do it anyway. Here we go. So what we're going to be doing is we're going to try to find all of the solutions on what's called an interval. And this interval is just a range of the values that you can get. Because if you can go around the circle as many times as you want, then there are going to be multiple options, multiple answers. But we're just going to look at the ones that are between 0 and 2 pi. And when I say that, I mean there is one rotation around the unit circle. So we're just looking about that much of the space. Okay. So what we're figuring out for this first one is, well, what tangent values or what angles give us the tangent value 0? So this says what angles have tangent of 0? Well, I remember that tangent is y over x. And so I'm looking for the two places on the unit circle where the y values are 0, because where the y values are 0 is the only places where 0 over anything would be 0. Okay, so all right, so what angles have tangent of 0? Well, 0 has it, and then we had pi, and then I'm also going to include 2 pi just for now, and maybe we'll see why we're going to do that in a second. But then these are the angles that have tangent of 0. And so this is what's equal to theta over 3 now. So I took this theta over 3, I asked this question, and then I figured out, well, these are my answers. These are some of my answers. Okay, so then now we can multiply by 3 to get these. But what we're going to do is we're going to multiply each of these by 3. So we're going to say, okay, well, 3 times 0 is 0. 3 pi or 6 pi. Well, only one of these is in this interval, and the only one that is in that interval, in the range that we're looking for, is 0. So we're going to write theta equals 0. For the next one, this one is a little bit, maybe there's a little bit more to with this one. Let's see. We are looking for the angles. What angles have cosine of negative 3 square root 3 over 2? Well, I'm thinking, okay, well, that's got to be here and here on the unit circle. So we're going to write theta over 2 equals, well, this one would be 5 pi over 6 or 7 pi over 6. So these are the ones that have that cosine. So we could write cosine inverse of square root 3 over 2. The problem is using this in your calculator is going to give you a decimal, not exact answer, and we want to stick in those exact answers. Okay, so these are sort of my two options, or I could go around the circle more times, but if I go around the circle more times, then I'm already outside of this range, so that doesn't really help. So to get theta by itself, we're going to multiply by 2, and I get theta equals 10 pi over 6. By the way, that reduces down to 5 pi over 3. And then this one gives me 14 pi over 6, or that would be 7 pi over 3. Well, this one is bigger than 2 pi. And so because it's bigger than 2 pi, it's not in this range that we want to work with, so we're going to cross it off. The only solution that we have here for this one is 5 pi over 3. Okay, so let's do the next one. The next one says -2 times the tangent, so I'm going to divide both sides by -2. And I get the tangent of theta over 3 equals -1. Okay, so where is the tangent equal to -1? So tangent inverse of -1 equals theta over 3. Well, where is the tangent equal to -1? Well, on the unit circle, the two places are here and here. Just kidding, I lied. Here and here. Those are the two spots I'm talking about. Okay, so the places where that is, this is 3 pi over 4. And this is 7 pi over 4. But if we are trying to say, well, theta over 3 is equal to that, then we need to multiply both by 3. So let's do that. So we're going to get 9 pi over 4, and we're going to get 21 pi over 4. Well, both of these theta equals. Both of these are greater than 2 pi. And so since they're greater than 2 pi, and the reason that I know that is because 9 is 8 plus 1, and so 8 is 2 pi, 8 pi over 4 is 2 pi, 9 pi over 4 is bigger than that. And then if that one is bigger than that, then 21 pi over 4 better be. So there are actually no solutions on the interval 0 to 2 pi. Okay, let's proceed. Next one. Here we go. Let's add 3, add 3. 3 is equal to 6 over 2, and so I'm going to end up with sine of theta plus pi over 3 equals -1/2. So now we're asking, okay, what sine values are equal to theta plus pi over 3? So what angles have sine -1/2? Well, on the unit circle, the two places are here and here. So let's see. This would be 7 pi over 6. And the other place is 11 pi over 6. So the next step would be to subtract pi over 3 from both sides. And so now we need a common denominator. So this would be like 2 pi over 6. Okay, so we're subtracting, and so we get, let's see, theta equals 5 pi over 6 or 9 pi over 6. 9 pi over 6 reduces to 3 pi over 2. So there are my two answers. So here's the thing. These two are both in this range right here. And so because of that, these are my two solutions, and they're in that range. So that means that we have found our solutions. I think I'll do this one by graphing, and so I'll show you that one later. But this one I want to do by hand, so let's do it. So we're going to subtract 5 from both sides, and we get 1 equals the cosine of theta plus 5 pi over 6. So let's see. Where are the places on the unit circle where the cosine is 1? Well, there's actually really only one place. So cosine inverse of 1 is equal to theta plus 5 pi over 6. And the only place I can think of on the unit circle is, well, it's the place where the x value is 1, and so that's on the right side there. We usually call that 0 or 2 pi, so I'm going to use both of those solutions. So 0 or 2 pi equals theta plus 5 pi over 6. So to get theta by itself, we're going to subtract 5 pi over 6. So we need a common denominator here, so we're going to have negative 5 pi over 6, and then this would be 12 pi over 6. And so if we're subtracting 5 pi over 6, we're going to get 7 pi over 6. So these are my two solutions, but the thing is, this one is negative, and so it's not in this interval, in this range. And so our only solution is just 7 pi over 6 here. I'll do this graphing one on the graphing calculator on the computer, and then that's all I have for you.